Let's go! And we say bye-bye. And we say bye-bye.
Hello, chat. Hello, Panda. Hello, Kip. Hello, Sack. Hey. How we doing, guys? Hi. We we are doing some things today. Himmel so Joe Poo Opris. Yeah, him, Laura Kate. It has been so long since I've spoken to you. Hello. Yeah, you can kind of see an arm like come in and out of existence. I'd just be laying. Yeah? Yay. Oh. I would never burp. You're welcome.
Day. So
Hang on.
We started by talking about those command line arguments that Clang uses, whereby anything after the command that you type at a prompt, be it make or Clang or even CD in Linux, any word thereafter or something cryptic like -o is a command line argument. It's an input to the command. It's different from a function argument because a function argument, of course, is an input to a function. But it's the same idea. It's just different syntax after the $sign at the prompt. Well, it turns out that command line arguments are something you can now use in your own programs by accessing words after the prompt. And let me propose that we invent this as follows. Let me propose that we switch back to VS Code here. And I'll open a new file here called greet.c. So in greet.c is going to be a program that very simply greets the user. Had we written this last week, we would have done this. Include cs50.h, and then include standardIO.h, and then int main void. And then we might do something simple like string name equals get string, quote unquote, what's your name question mark. And then we would have printed out, as always, hello, comma, %s, and then plugging in that name. So this is the same program we've implemented many times, just to make sure it works. Although, nope,
Yeah.
it's not quite the same program. Semicolon's in the wrong place. This now is the same program. So make greet /greet, and I'll type in my own name, hello, David. So we're back there. Now, what's arguably a little annoying about this program, if I type in something else like Carter, enter, you know, I have to run the program, wait for the prompt, type in my name, hit enter. And that's fine. But imagine if every program worked like this, like make. Suppose you could only type make. Then you wait for a prompt. Then you type the name of the program you want to make. Then you hit enter. Or worse, in Linux, when you have to change directories, as you might have for problem set 1, what if you had to type cd, enter? Now type the name of the folder you want to change into, enter. I mean, it just slows life down. And so it just gets annoying quickly. So command line arguments just let you express your whole thought.
That's crazy. It looks so weird. Can tell he's got ankles, but it's like strange. The thing. Ah, give me a second, chat. Hey, Jim. Welcome back. How is you? What's up, scrimblos and bimbos? Oh, damn. How was your trip into the city? Hello, Jim. Yeah.
All at once. So how can I do this? Well, if I want to express the notion of command line arguments in my code, I could do something like this. I could, for the very first time, go up and get rid of this void, which as of today means this program takes no command line arguments. And I can change it to exactly this: int argc string argv with brackets. Now, it's cryptic, admittedly, and let me zoom in, but I think we can perhaps infer now what's going on. If main now does not have void as its input, which means it takes no arguments, surely the spoiler here is that now main will take command line arguments somehow. Any guesses as to what argv is or will be? What might this represent? It's an array of strings, right, by way of the syntax, yeah? Exactly. It will be all of the characters, or really all of the words that you type at the prompt. argc.
Went well, took the subway down to some obscure record store and ended up in the heart of Chinatown. It was a fun experience. Oh, yeah.
As an int, any guess? Argument count is what it generally stands for, though technically type at the strings, right, by way of the syntax. I think we can perhaps infer now what's going on. If main now does not have void as its input, which means it takes no arguments, surely the spoiler here is that now main will take command line arguments somehow. Any guesses as to what argv is or will be? What might this represent? It's an array of strings, right, by way of the syntax, yeah? Exactly. It will be all of the characters, or really all of the words that you type at the prompt. argc as an int, any guess? Argument count is what it generally stands for, though technically you could call these things anything, but this is the convention. Because I claimed earlier that arrays don't keep track of their own length, if you want to know how many words the human typed at the prompt after your program's name, you have to be told not just the array of the words, but the length of that array. The strings you can figure out the length of using strlen, but you can't figure out the length of the array of strings, the collection of words that the human typed in.
He does not appreciate that, does he?
So how can I now use this? Well, let me go ahead and do this. Let me go ahead and change this program now just to be printf, quote unquote, hello, comma, %s \n, then argv bracket 1. So this is not the best version of my code yet, but it's my first. Make greet, and now let me do /greet David all at once. Enter, hello, David. Now let me run it again. /greet Carter, enter, hello, Carter. You know, it's a marginal improvement, but I don't have to wait for getString to prompt me to hit enter. It's just speeding things up, you know, twice as fast. One less command to type in. But I deliberately did bracket 1, but what's the beginning of argv? It would be bracket 0. Well, what's that? This is sometimes useful, though for now it's not. Suppose I recompile my code and run this program now, greet David. Anyone want to guess what's in argv 0? Say again? Greet. Enter. Hello /greet. So if you want, sort of Inception style, your program to figure out what its own name is, or at least how it was executed at the command line, at the terminal, you can look at argv 0. In general, probably not that useful. Probably better to start looking at bracket 1, which was the first word after the program name. And if there were more, I could do this. How about argv bracket 2? Let me add in a second %s. Let me recompile greet. Let me do /greet David Malin, enter, and that too now works, taking in 2 words at the prompt. If I really want to be smart at this now, I could do something like this, though. How about if the count of arguments, aka argc, equals 2, then assume that the human typed in only their first name and do printf hello, comma, %s, \n, and then argv bracket 1. Else, if the human did not provide exactly 2 arguments, the name of the program and their own name, let's just print out a default value, lest they forgot their name or they typed in 2 names or 3 names. Let's just do hello, comma, world as a default, and we'll just ignore what the human typed in. If I recompile this, make greet, I can do /greet and David again, enter. Oops. Sorry, what am I missing? Yeah, so newbie mistake, else. All right, make greet again, /greet David, enter. There's my hello David. But if I omit my name, I just get the generic, like a default value. And if I get a little curious and I type in both names, then I get ignored too. Why? Because I just haven't built in support for argc of 3. I can do anything I want, but now we have access to these kinds of building blocks. All right, what else might I do here? Well, it turns out there might be some final features for us to now execute. Notice, though, that in C, despite what you might see in books or online tutorials, nowadays, the 2 official formats for defining a main function are either this, which we've been using now for 2+ weeks, or now this, whereby you change the void to int argc, and then for now, string argv, and then empty brackets. And we'll see that this too is a simplification, some training wheels, if you will. But for now, those are the 2 forms. Even though you will see in online tutorials and even books, some people use main in different ways. These are the 2 now to keep in mind. And I'll note that these command line arguments are kind of all over the place. Didn't probably expect to see this word on the screen here. And what does it mean? Well, it turns out that for decades, there's actually this program that comes with Linux systems in particular called cowsay. Why? Probably because someone had too much free time once and decided to write a program that creates ASCII art out of a cow saying something textually on the screen. But you use cowsay, just for fun, by way of command line arguments. So for instance, let me propose that I go back to VS Code here. Not because I want to write any code, but I just want to use my terminal window. And let me maximize my terminal window here. And let me go ahead and type in something like, how about cowsay space moo. So cowsay is not a program I wrote. It's been around for decades, but we installed it in VS Code for you in the cloud. It takes at least 1 command line argument. What do you want the cow to say? I can say cowsay moo and hit enter, and voila, there's my ASCII art of a cow saying moo on the screen. It can say multiple words, so I can say hello world, enter, and now it says hello world. So this is just an example of a silly program that uses command line arguments, but it takes others too. Just like Clang used this convention of hyphens to change the output of the program, dash something is just a super common convention with command line arguments when you want a very terse notation for some option, like output. In cowsay, I read the documentation, and it turns out there's a -f command line argument that allows you to change the appearance of the cow, if you will. So if I do cowsay -f duck, and then some other word like quack, it's no longer a cow. That command line argument turns it into a tiny, adorable duck instead. And then lastly, just for fun, because I spent way too much time playing with command line arguments, cowsay -f dragon, and then how about like rar, enter. You can even get this on the screen here. So this too is just an example of what you can do with these command line arguments now that we have this building block. And there's one final thing we can now do with code. There's one last feature today that we'll introduce before we now connect all of these dots to readability and encryption by talking lastly about something called exit status. It turns out that whenever your main function exits, it returns a secret integer that you can figure out as the programmer or an advanced user what it was. And these exit codes, exit statuses, are typically used to indicate errors. So for instance, over the past couple of years, if you've used Zoom and you ever got some kind of error, you might have seen a screen like this. It's usually not that helpful. Maybe tells you to click report problem or contact support. But very often in our human world on Macs, PCs, and phones, you see cryptic error codes, like literally numbers that probably only Zoom knows, or Microsoft, or Google, or whatever company wrote the software you're using. But that number corresponds to a specific error that some human somewhere knows might very well happen. These are used similarly.
Wow. It is. You have fun. Obviously, Claudia is very happy. No, aeroplane is.
Although under a different name that will
Yay. Yay.
talk about later.
Bye. Hey, Shady. How you doing, buddy? Kate's excited you're here, bud.
The term.
Yeah, she's off to go watch Lucifer. What's this? I've been over the last couple days, I've been Hi Kate? Yeah. She's running away with Claudia at the moment. Do you want me to, or are you gonna come back? Oh, okay. Meow. This is me learning code, Shady. Yesterday I restarted this. I tried to do this earlier on in the year, but I got super distracted a bunch of times. And so, and then I would like spend, like, I would get like hyper focused on it and then do like lots and lots and lots and lots and lots and lots of it. And then I'd get burnt out and then I would stop. So now I'm trying to do a little bit each day. And that way, even though I enjoy it and I stop, it still means that I can look forward to it like tomorrow or the next day. And I've been staying a little bit early. Baby's first syntax error. Okay, he's just maybe, Jim, maybe.
On the web as well. Have you ever seen this, maybe not character, but number? So 404 means what?
Welcome to the Matrix. Yeah, do you want to take the red pill or the blue pill? Or the secret black pill? Or the, I don't know, there's like other shit pills that people like to do too. Huh? What? Hi. I'm gonna go hit up my boy Andrew Tate and we're gonna do all the pills together. You like Tylenol? Yeah, that's a good pill to take.
So error, yes, but really not found. So why? I mean, this is the most arcane thing, and we'll talk in a few weeks about like what this and other.
It's like, I'm just gonna yawn in the middle of me talking. All right, chat. You can appreciate that. There's like some things I want to do for stream that I think would be fun, and there's some other like things that I want to do as well. So learning code will help with that.
Numbers mean, but numbers are all around us in technology, and they very often mean something to the technical people who wrote the software, less so to humans.
And I find it interesting.
Why so many of us recognize 404 is kind of weird, that like that's been around long enough that we all know it, but it really is just a special number that represents an error of some sort. So it turns out the last thing we'll reveal today about what we've been taking for granted for 2 weeks is what the int is in main. We've seen just a moment ago that the thing in the parentheses, which up until now has been void, which means no command line arguments, now int argc string argv brackets just means yes, command line arguments. And we've seen how to access them. So the last piece of the puzzle, honestly, of all the cryptic syntax the past 2 weeks, is just what int means. Int is always there for main, and it indicates that main will always return an integer, even though you and I have never done so explicitly.
I feel like there would be a big demand for this skill right now. Yeah, that also helps as well, Shady. Because there is a big demand for this. So, eventually, I'd like to, you know, have a job with it. But, like, as of right now, I'm just going small goals. Learn it, get some, like, fun stuff for stream going for it. Get the projects, like, progressively, like, you know, bigger, and then like apply for jobs.
Usually main returns 0 by default. But it would be weird if you saw an error message saying 0. So 0 is just hidden. You would never see it on the screen. But it's happening automatically by way of how C is designed. So let me write one final program here. I'll call it, for instance, status.c to show you these exit statuses. Code of status.c. And then up here, let me do something simple like include cs50.h, then include standardio.h, and then int main. Let's use a command line argument. Int argc string argv. So that's copy paste. But now let's do this. If argc does not equal 2, why don't we do something like this? Let's not just default to hello world like last time. Let's yell at the user. So let's say something like printf missing command line argument, so that they know they screwed up and they need to run the program again correctly. Else, let's go ahead and say print out, as before, hello, comma, %s, and then plug in argv bracket 1, so the human's name from the prompt. Now at this point, let me go ahead and run status, /status, and I'll type nothing first. I get yelled at. This time I'll type it again, /status David, and it works properly. But now let me show you a somewhat secret cryptic command. You can type this at your prompt, and it's just a coincidence that there's another $sign. Echo $? Totally arcane, but it allows you to see what exit status your program has ended with. So let me run this again the wrong way. /status. OK, I get the error message. What was secretly returned? I can't see it. There's obviously no error screen. But by typing echo $? I can see that, oh, my program automatically, by default, returns 0. However, if I run it again correctly, /status David, enter, this is the correct version. But if I run echo $status again, it's still entered with 0. And long story short, this is just a missed opportunity. When something goes wrong, why don't I return a value other than 0? 0 by default means success, and it's always there automatically. But you can control this. I can go into my code here and return 1. Else, if something works fine, I can return 0 by default. And honestly, if I omit the return 0, again, 0 automatically is returned. So let me go ahead and, though, be explicit, just so I know what's going on. Make status again, /status. And let's do this correctly with David. Enter, hello, David, echo $, 0. So all is well. But now if I do /status and nothing, or multiple things, but not just David, enter, I get the error message. But now if I do echo $, voila, there now is the 1. So what does this now mean? This is, in the graphical world, we would just show something like this on the screen, which is a little more informative to the user. But even in the Linux world, where you don't have a GUI necessarily, even for the programs we've written, you can check these exit statuses. And in fact, more comfortable, more advanced programmers, when they write code that calls programs, be it cow, say, or anything else, you can encode, check what the exit status is of a program, and then decide, did my program work or did it not? And now let's connect the final dots before we adjourn for some fruit snacks. Cryptography, namely one of the applications this week via which you'll be able to send, if you will, secret messages, and better yet, decrypt secret messages. This will be in addition to perhaps analyzing the readability of text using heuristics, like we identified at the start of class 2. So cryptography is just the art, the science of encrypting information, scrambling information, so that if you have a secret message to send in so-called plain text, you can run it through some algorithm and turn it into what's called ciphertext, thereby encrypting it. And only someone who knows what algorithm you've used and what input you've used to the algorithm, theoretically, can decrypt that process and convert it back to the original message. So if we use our mental model from last week, here is a problem. Here is an input and output. The goal, I claim here, is to take some plain text, like the message you want to send. Think back to grade school. If you ever passed a note to a friend or to your crush saying, I love you, it's a little awkward if the teacher or someone else intercepts the paper, and in English it just says, I love you, or whatever it is. It'd be nice if you had at least encrypted it in some way. But the other person needs to know what algorithm you used and what inputs you used to that algorithm, so that ultimately they can decode the so-called ciphertext, which is the output. So what goes inside of the box today? Well, an algorithm, as it relates to cryptography, is called a cipher. And a cipher is a fancy name for an algorithm that encrypts text, from plain text to ciphertext. The catch is, there needs to be not just the algorithm, there needs to be an input to it. And so, for instance, you might draw the picture like this for the first time today. And we've seen this in code. You can give multiple inputs or arguments to functions. So in this black box, can you imagine passing in the message you want to send and then some secret? So for instance, suppose that the simplest thing I could think of as a kid was, instead of sending the letter A, why don't I write the letter B? Instead of the letter B, why don't I write the letter C? So I can kind of shift the English alphabet by one space. So A becomes B, B becomes C, dot, 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 Z becomes A. You can wrap around at the end. And let's assume no punctuation in this part of the story. So that's a very simple algorithm. Add a value to each letter and send the value as the ciphertext. And now the teacher, the classmate, they have to know that you use not only this rotational algorithm, also known as a Caesar cipher, they also need to know what number you use. Did you add 1 to every letter, 2 to every letter, 25 to every letter? Now, if they're super smart, and probably not the young age in this story, they could also just try all possibilities. And that would be an attack on the algorithm. This is not a sophisticated algorithm. But it's enough to send a message in class. So if the two inputs now are hi as the plain text message, and 1 as the so-called key, the secret number that only you and the other person know, you might be able to encrypt a message from one way to the other. And so in this case, for instance, hi would become IJ, exclamation point. In this version of the algorithm, we're not going to bother with numbers or punctuation. We'll only operate on A through Z, be it uppercase or lowercase. So now if you were to receive a slip of paper in class with IJ on it, you know, you, the recipient, would know what it is so long as you know that the sender used 1, because you just reverse the algorithm and you subtract 1 instead. The teacher, you know, they probably don't know what this means, and they're not going to spend time hacking the message, so it just looks scrambled to them. And that's what we get from encryption. Someone who intercepts it, be it in class or in the real world, on the internet or anywhere else, can't actually figure out, ideally, what it is you have sent. The opposite, of course, is indeed called decryption, but the process is the same. We now pass in -1. And so how about this? Why don't we end with a demonstration here? UYJTXBTDT50. There's a bit of a tell there. If we pass that in and do -1, well, how do we get out the plain text originally? Well, if this is the ciphertext and we subtract 1 from each letter, I think U becomes T, I becomes H, J becomes I, T becomes S, X becomes W, B becomes A, T becomes S, D becomes C, T becomes S, and this was indeed CS50. Have a duck on your way out and some snacks in the lobby. This is CS50, and this is week 3 already, wherein we'll take a look back actually at week 0, where we first began. And in week 0, recall that everything was very intuitive in a sense. We talked not just about representation of information, but algorithms. And we talked about tearing a phone book again and again, and that somehow got us to a better solution. But today we'll try to start formalizing some of those ideas and capturing some of those same ideas, not in pseudocode just yet, but in actual code as well. But we'll also consider the efficiency of those algorithms, like just how good, how well designed our algorithms actually are. And if you recall, when we did the phone book example, wherein I first had an algorithm searching 1 page at a time, and then second, went 2 pages at a time, and then third, started tearing the thing in half, recall that we, with a wave of the hand, kind of analyzed it as follows. We proposed that if the x-axis here is the size of the problem, like number of pages in a phone book, and the y-axis is the time required to solve the problem in seconds, minutes, page tears, whatever your unit of measure is, recall that the first algorithm was this straight line, such that if you had n pages in the phone book, it might have this slope of n, and there's this 1-to-1 relationship between pages and tears. 2 pages at a time, of course, was twice as fast, but still really the same shape. The yellow line here indicating that, yeah, it's n over 2, maybe plus 1 if you have to double back, as we discussed, but it's really still fundamentally the same algorithm, 1 or 2 pages at a time. But the third algorithm, recall, was this one here in green, where we called it logarithmic in terms of how fast or how slow it was. And indeed, the implication of this algorithm was that we could even double the size of the phone book, and no big deal, one additional page tear, and we take yet another 1,000-page byte out of the phone book. So today, we'll revisit some of these ideas, formalize them a bit, but also translate some of them ultimately to code. And all of that now is possible because we have this lower level understanding, perhaps, of like what's actually inside of your computer. This, of course, is your computer's RAM, or memory. And recall that if we kind of start to abstract this away, your computer's memory is really just a grid of bytes. In fact, we don't have to look at the hardware anymore. And we looked at a grid of bytes like this, whereby each of these bytes could be used to store a char, an int, a long, or even an entire string at that. But let's focus perhaps just on a subset of this, because last week, of course, we emphasized really arrays, storing things in arrays. And that allowed us to start storing entire strings, sequences of characters, and even arrays of integers if we wanted to have multiple ones and not just multiple variables as well. But the catch is that if you look inside of an array in the computer's memory, and for instance, suppose these integers here are stored, it's pretty easy for us humans to glance at this and immediately find the number 50. You sort of have this bird's eye view from where you're seated of everything on the screen, and so it's pretty obvious how you get to the number 50. But in the world of computers, of course, it turns out that this is hardware, and computers, for today's purposes, can only do one thing at a time. They can't just take it all in and find instantly some number like 50. So perhaps a decent metaphor is to consider the array of memory inside of your computer really as a sequence of closed doors. And if the computer wants to find some value in an array, it has to do the digital equivalent of opening each of these doors one at a time. Now, how can code do that? Well, of course, we introduced indices or indexes last week, whereby we, by convention, call the first element of an array location 0, the second location 1, the third location 2, and so forth, so-called zero indexed. And this allowed us to now bridge this conceptual world of like what's going on in memory with actual code, because now we had this square bracket syntax via which we could go searching for something if we so choose. And it turns out if I now paint these red instead of yellow, it would seem that we actually have a pretty good physical metaphor here standing in place for what would be a computer's array of memory if, for instance, you're storing some 7 numbers like that. And so today we begin with a look of a specific type of algorithm. That is for searching. Like, searching is all over the place. All of us have probably gone to google.com or some equivalent like already multiple times per day. And getting back answers fast is what companies like Google are really good at. So how are they doing that?
Hello, code. Good morning. We're learning code.
How are they storing information in computers' memory? Well, let's consider what this really is. It's really just a problem, as it was back in week 0. The input, though, to the problem for now might be this array of 7 lockers. So that's the input to the problem inside.
6 a.m. for you? Damn, it's 5 p.m. for me, man. I hope your morning's going good, at least. It'd be Tuesday for you, wouldn't it, bud? Yes, Monday for me.
Of which is a number, and maybe for simplicity now, we just want a yes, no, a true, false answer.
Good, yeah, just go back from the... Yo! You go to the gym early, bro? What time do you get there? What, like... Jesus, you start at like 5 or some shit? How am I? I'm really good, my friend. Learning some code, as you can see. You go at 5? Bro, so what time do you leave the house to get there at... Oh, wait. So you leave at 5. How far away is it? You leave 10 to 5. So you arrive at 5, so it's about probably 10 minutes away. Proud of you, bro. Hell yeah. That's really good.
Bool, that is to say, of whether or not some number like 50 is in that array. It's not quite as fancy as Google. That doesn't just tell you, yes, we have search results. It actually gives you the search results. But for now, we'll keep it simple and just output as part of this problem, yes or no, true or false. We have found the number we're looking for given an input like that array. But it turns out, inside of this black box that we keep coming back to, there's all sorts of possible algorithms. And we talked about this at a high level conceptually in week 0 with the phone book, but today let's consider it a little more concretely by way of a game that some of you might have grown up with, namely Monopoly. And so behind these doors, it turns out, will be hidden some denominations of Monopoly money. But for this, we now have 2 volunteers, if you'd like to greet the world.
Hi, I'm Jackson.
Yay. Hi, my name is Stephanie.
And do you want to say a little something about yourselves, years, house, storm?
I'm a first year living in Matthews.
Nice.
And I'm a first year in Canada.
Nice. Well, welcome to our 2 volunteers.
So it was Monday for you? It is, buddy. Hello from Monday. Did your gym session go good, my friend? How long have you been going for?
So why don't we do this? Would one of you like to volunteer the other to go first?
I'll go first.
Okay. All right, so Stephanie's up first, and behind one of these doors here, we've hidden the Monopoly Money 50. And so we'd like you to find the 50. We'll tell you nothing more about the lockers, but we would like you to execute a certain algorithm. And in fact, I'm going to give you some pseudocode for this, and I'm going to give you the name for it. It's called linear search. And
Good session. Been doing gym for like maybe 2 years. Hey, that's the way, buddy. Proud of you.
as the name implies, you're pretty much going to end up walking in sort of a straight line. But how are you going to do this? Well, let me propose that in a moment, your first step will be to think kind of like a loop. For each door from left to right, what do we want you to do on each iteration? Well, if 50 is behind that door, then we want to go ahead and have you return true and sort of hold up the 50 proudly, if you will, for the group. Otherwise, if you get through that whole loop and you haven't found the number 50, you can just throw up your hands in disappointment. False. You've not found the number 50. So to be clear, step one is going to be for each door from left to right, how would you like to begin? Yep. Oh, and then, yep, there we go. Yep. And if you'd like to at least tell, good acting here. What have you found instead?
It's not 50, but 20.
Oh, okay. So step one was a fail. So let's move on to step two. Inside of this loop, what are you going to do next?
I'm going to move to the next door.
Okay.
Anyways, man, hope you have a good stream. I'm going to get ready for the day. Have a good one. Yeah, no worries, buddy. You be good, okay, man? I hope you're looking after yourself. Kicking butts, taking names.
Almost.
Oh, okay, almost, sort of. A 500 instead. Next locker.
I would rather take. No.
Okay, we're not telling the audience?
That was a 10.
Okay. So keep going. This is step three now.
Oh, man.
5, okay. A few more lockers to check.
A little sad, guys.
All right, second to last step.
This one,
No.
kind of close.
All right. And finally, the last step. Clearly, you've been perhaps set up here.
Let's go.
All right. So the number 50. And Stephanie, if I may, let me ask you a question here. So on the screen, this is the pseudocode you just executed. Suppose, though, I had done what many of us have gotten to the habit of doing when you have a if condition. You often have an else branch as well. Suppose that I had done this now, and I'm marking it in red to be clear this is wrong. But what would have been bad about this code using an if and an else, might you say? Any instincts?
Then you would end up like canceling the code before you found the 50.
Yeah,
And
exactly.
it would just be eternally sad.
Indeed, when Stephanie had opened the first locker, she had found 20. 20, of course, is not 50. She would have decreed false, but of course, she hadn't checked all of the rest of the lockers. So that would seem to be a key detail that with this implementation of the pseudocode, we actually do go through as we did and only return false, not even with an else, but just at the end of the loop, such that we only reach that line if we don't return truer earlier than that. Well, let's go ahead and do this. Let me take the mic from you if you'd like to take a seat next next to Jackson. Jackson, in just a moment, we'll have you come up. Carter, if you don't mind reorganizing the lockers for us. But in the meantime, let me point out how we might now translate that same idea to code. Pretty high level, pretty English-oriented with that pseudocode. But really now, as of last week, we have syntax via which Stephanie and soon Jackson could treat this locker, this set of lockers, as really indeed an array using bracket notation. So we can now get a little closer in our pseudocode to actual code, and the way a computer scientist, for instance, would translate fairly high-level English, pseudocode like this, to something that's a little closer to C, or any language that supports arrays, would be a little more cryptically like this. But you'll see more of this syntax in the coming days. For I from 0 to n minus 1. This is still pseudocode, but that's kind of like the English-like way of expressing what we've come to know as a for loop. If 50 is behind doors bracket I, so I'm assuming for the sake of discussion that doors now is the name of my variable, this array of 7 doors, but then the rest of the logic, the rest of the pseudocode really is the same way. And so you'll find in time that programmers, computer scientists more generally, when you start expressing ideas, algorithms to someone else, instead of maybe operating at this level here, you now have in your vocabulary really a new syntax that you can be a little more specific, not getting so into the weeds of writing actual C code, but at least now doing something that's a little closer to manipulating an array like this. So Jackson, would you like to stand on up? All right. Yes, yes, support for Jackson here too.
Hello, hello.
Nice.
Hello, Eno.
Here now.
How you doing, buddy? It's good to see you. Learning some code.
Now, I'm going to allow you an assumption that Stephanie did not have. Stephanie clearly was really doing her best, searching from left to right, using linear search, as we'll now call it. But they were pretty much in random order, right? There was a 20 over there, there was a 1 over there, and then a 50. So we deliberately jumbled things up and did not sort the numbers for her. But Carter kindly has just come up to give you a leg up, Jackson, by sorting the numbers in advance.
Doing okay, but like, the actual fuck. What? What happened, Enar? You okay, my friend? It's 12:25 here, and someone is literally hammering something. He's like fixing something? At that time? Surely you're not supposed to make noise after like 10 or 11 or some shit. What the fuck is this? Yeah, bro, that's really rough, you know? Is there anything you can do about it, my friend?
And we'd like you this time, much like in week 0, to do something again and again, but this time using what we'll now call binary search. It's exactly the same algorithm conceptually as we did in week 0, but if we translate it to the context of this array, we might say something like this. The first step for Jackson might be to ask the question. If 50 is behind the middle door, where presumably he's done some mental math to figure out what the middle is, then he's going to just return true. And hopefully we'll get lucky and 50 will be right there. Of course, there's 2 other possibilities at least, which would be what? 50 is with respect to these doors? Yeah, so to the left or to the right, alternatively. So if 50 is less than the middle door, then presumably Jackson's going to want to go left. Else, if 50 is greater than the middle door, he's going to want to go right, much like I did physically last week with the phone book, dividing and conquering left to right. But there's actually a 4th case. Let's put it on the board first. What else might happen here that Jackson should consider? Yeah. Oh. It's not there.
You thought you'd open your windows because today and next 2 days is going to be 30 C+. So on the night I want some cold air, cool down my apartment. But now I might just close them because of the noise. Yeah, bro, that is rough, man. Surely they're not allowed to be doing it at that time of night. Do you have like noise control or something you can call, buddy?
So let me actually go back and amend my pseudocode here and just say, Jackson, if we don't hand you any doors at all, or eventually, as he's dividing
throw a
and conquering,
brick
if
at
he's
him.
left with no more doors, we have to handle that
Hell
situation
yeah.
so that the behavior is defined. All right. So with that said, Jackson, do you want to go ahead and find us the number 50 and walk us through verbally what you're doing and finding?
All right, so it looks like this one is the middle door. So I'm going to open it. But it's 20, not 50.
Oh,
Sad.
okay. What's going through your head now?
So now I'm looking, because 50 is higher than 20, I want to look to the right
Good.
and look for the new middle door, which would be here.
Nice.
And it's 100.
Oh.
Sad. But 50 is less than 100. So now we know to look left, which would be here. And ta-da!
Nice. Very well done this time around, too. So thank you first to our volunteers here. And in fact, since you're a fan of Monopoly, as we're so informed, we have the Cambridge edition of Monopoly with all your Harvard favorites. Here you go.
Great. Thank you so much.
Thank you to our volunteers for finding us 50. So that was more popular than we expected. So here.
That's so cool. Maybe that will break what he's fixing. Then he'll be hammering for longer. Not a smart idea. I'm sorry, Enar. I know it sucks when people do shit like that.
Here we can translate this one more time into something a little closer to code. And again, still pseudocode, but here now might be another formulation of exactly what Jackson just did, just using the nomenclature now of arrays, where you can be a little more precise with your instructions and still leave it to someone else to translate this finally to code. But here we have, same question at the beginning. If no doors left, return false. If 50 is behind doors, bracket middle. So I'm assuming here, because this is pseudocode, that somewhere I've done the mental math or the actual math to figure out what the index of middle is. For instance, if these are 7 doors in an array, this would be location 0, 1, 2, 3, 4, 5, 6. So somehow I've taken the total number of doors, 7, divided by 2 to find the middle. That's 3.5. We have to deal with rounding, but suffice it to say there's a well-defined formula for finding the middle index, given the total number of lockers, divide by 2, and then round accordingly. So that's presumably what Jackson did just by counting or in his head to find us door number 3. Not the third door, the fourth door, but door bracket 3. So this is just saying if 50 is behind doors bracket middle, return true. That was not the case. He found a $20 bill instead. Else, if 50 is less than the doors bracket middle, go ahead and now.
Oh well, had worse. Still gonna try to get some sleep though. How's the coding going, by the way? Pretty good. I mean, this is the second day that we've been doing it. Still learning's going pretty good. Yeah. Pretty good. Still learning stuff. Still enjoying it. Just gotta make sure I pace myself and not go nutsoid like before. Am I okay watching? Only watching? At the moment, it seems like this particular part and the part before don't require me to be writing anything. Also implementing. Yeah, I want to be implementing as well, my friend. I signed up to like a free course today as well. I was having a little look at it. Just, I got recommended it by Loco yesterday. So I'm having a look at that too. I haven't like gone through it completely yet because the beginning part is like just talking about like basic parts of what you're going to learn and everything. And like, I had a quick look at it, and that's why I decided to do the course in the first place. So it talks about like code and shit. So like I don't really need all the like this is what we're gonna learn and like this is what we're going through and no. I hate that part of like study because I've already agreed to that part. So like. I sound confused? No. I'm not confused. I just don't like it when they give me, like, I feel like unnecessary information. Coding's making me crazy. True. Just like the hammer's making you crazy, my friend.
It's interesting. Search doors 0 through doors middle -1. So it's getting a little more into the weeds now, but if middle is 3, this one here, well, we want to now have Jackson search if 50 had been, if the number had been less, we want to start at bracket 0 and go up through this one. When we deliberately subtract 1, because what's the point of looking in the same locker again? We might as well do 0 through middle -1. Else if 50 is greater than doors bracket middle, which it was, what did we then do? Jackson intuitively searched for doors middle +1 through doors n -1. And honestly, it gets a little annoying having the
Have fun. Good luck learning. Thank you, my friend. You have a good night's sleep, okay, if you can. You're gonna try to get some sleep? No worries, my friend. You be good. Lights are banging now.
pluses and the minuses here, but just think of what it means. This is the middle door, and Jackson then
At least is that, my friend.
Doors middle +1, because there's no point in searching this one again. And then the last element in any array of size n, where n is just our go-to number for the size, is always going to be n-1. It's not going to be n, it's going to be n-1 because we always start counting at rays.
And we say bye-bye.
So here then we have a translation into
Oh, yeah. Be good, buddy. Thank you for the look.
pseudocode that's a little closer to C of this exact same idea. And here we come full circle to week 0. Like in week 0, it's pretty intuitive to imagine dividing and conquering a problem like this. But if you now think back to actually your iPhone, your Android phone, or the like, when you're doing autocomplete and searching the list, it's possible, if you don't have many friends or family or colleagues in the phone, you know what? Linear search, just checking every name for the person you're searching for, might be perfectly fine. But odds are your phone's being smarter than that, especially if you start to have dozens, hundreds, thousands of people in your contacts over the years. What would be better than linear search? Well, perhaps binary search. But there's an assumption, a requirement, which is what? Why was Jackson ultimately able to find the 50 in just like 3 steps instead of a full 7, like Stephanie? Because the array was sorted. And so this is sort of a teaser for what we'll have to come back to later today. Well, you know, how much effort did it take someone like Carter? How much effort does it take your phone to sort all of those names and numbers in advance? Because maybe it's not actually worth the amount of time. Now, someone like Google probably somehow keeps the database of web pages sorted. You can imagine it being super slow if when you type in cats or something else into google.com, if they searched linearly over their entire data set. Ideally, they're doing something a little smarter than that. So we'll formalize now exactly this kind of analysis. And it's not going to be so much mathy as it still will be intuitive. But we'll introduce you to some jargon, some terminology that most any programmer or computer scientist might use when analyzing their own algorithms. Let's formalize now what this kind of analysis is. So right now I claim binary search better than linear search. But how much better and why exactly? Well, it all comes back to this kind of graph. So this, recall, is how we analyzed the phone book back in week 0. And recall that indeed we had these formulas, rough formulas that describe the running time of those 3 algorithms. 1 page at a time, 2 pages at a time, and then tearing the thing again and again in half. And precisely, if you counted up the number of pages I was touching or the number of pages I was tearing, it's fair to say that the first algorithm, in the worst case, might have taken n total pages. It didn't, because I was searching for John Harvard at the time, which is somewhat early in the alphabet. But if I were searching for someone with the last name of Z, I would have had to keep going and going, in the worst case, through all n pages. Not as bad for the second algorithm, and that's why we do n divided by 2. And even that's a bit of a white lie. right? It's probably n divided by 2 plus 1 in case I have to double back. But again, I'm sort of doing this more generally to capture the essence of these things. And then we really got into the weeds with like log base 2 of n for that third and final algorithm. And at the time, we claimed anytime you're dividing something in half, odds are there's going to be some kind of logarithm involved. And we'll see that today. But today, we're going to actually start using computer science terminology. And we're going to sort of formalize this imprecision, if you will. We are not going to care generally about exactly how many steps some algorithm takes, because that's not going to be that enlightening, especially if maybe you have a faster computer tomorrow than you did today. It wouldn't really be fair to compare numbers too precisely. We really kind of want to, with a wave of the hand, just get a sense of roughly how slow or how fast an algorithm is. So the notation here is deliberate. That is literally a capital O, often italicized, referred to as big O. And so the first algorithm is in big O of n. The second algorithm is in big O of n divided by 2. The third algorithm is in big O of log base 2 of n. But even that is kind of unnecessary detail. When using big O notation, you really don't care about, we'll see, the smaller ordered terms, right? We're not going to care about the divided by 2. Because you know what? The shape of these algorithms is almost the same. And really, the algorithm itself is sort of fundamentally the same. OK, instead of 1 page at a time, I'm doing 2. But if you throw millions of pages, billions of pages at me, those algorithms are really going to kind of perform the same as n gets really large, goes off toward infinity. And the same is true for logarithms. Even if you're a little rusty, it turns out that whether you do the math with log base 2, log base 3, log base 10, you can just multiply one by the other to really get the same formula. So this is only to say a computer scientist would generally say that the first 2 algorithms are on the order of n steps. The third algorithm is on the order of log n steps. And we don't really care precisely what we mean beyond that. And this big O notation, as we'll see, and actually let me zoom out. If you can imagine suddenly making the x-axis much longer, so more pages on the screen at once, it is indeed going to be the shapes of these curves that matter. Because imagine in your mind's eye, as you zoom out, zoom out, zoom out, zoom out, and as n gets much, much, much bigger on the x-axis, the red and the yellow line are essentially going to look the same once n is sufficiently large. But the green line is never going to look the same. It's going to be a fundamentally different shape. And so that's the intuition of big O, to get a sense of these rates of performance like this. So here then is big O. Here is perhaps a cheat sheet of like the common formulas that a computer scientist, certainly in an introductory context, might use when analyzing algorithms. And let's consider for a moment which of our first 2 algorithms, linear search and binary search, fall into these categories. So I've ordered them from sort of slowest to fastest. So order of n squared. It's not something we've actually seen yet, but it tends to be slow because it's quadratic. You're doing n times n. That's got to add up to a lot of steps. Better today is going to be n log n. Even better is going to be n. Even better than that is log n. And best is so-called order of 1, like 1 step, or maybe 2 steps, maybe even 1,000 steps, but a fixed, finite number of steps that never changes no matter how big n is. So given this chart, just to be clear, linear search, let's consider the worst case. In the worst case, how many steps did it take someone like Stephanie to find the solution to the problem, assuming not 7 doors, but n doors? Yeah. So on the order of n. And in this case, it's exactly n. But you know what? Maybe it's arguably 2n, right? Because it took Stephanie a couple of steps. Like she had to lift the latch. She had to open the door. Maybe it's 3 steps. She had to show the money. So now it's 3n, 2n. But there, we don't really care about that level of precision. We really just care about the fundamental number of operations. So we'll say yes on the order of n. So that might be an upper bound, we'll call this, for linear search. And how about binary search? In Jackson's case, or in general, me in week 0, if there's n doors, how many steps did it take Jackson or me using binary search? In this case, it was literally 3, but that's not a formula. Yeah, so it's on the order of log n. And indeed, if there's 7 doors, well, that's almost 8. Just do a little bit of rounding. And indeed, if you take log base 2 of 8, OK, so that does actually give us 3. So the math actually checks out. And if you're not comfy with logarithms, no big deal. Just think about it intuitively. Logarithm of base 2 is just dividing something again and again. So on this chart, when we consider big O, which to be clear, allows you to describe the order of an algorithm's running time, like the magnitude of it, but it also describes more specifically an upper bound. So in the worst case, for instance, these are pretty good measures of how good, or rather of how bad linear search and binary search might be. Why? Well, suppose you're searching a 1,000-page phone book and the person's name starts with Z. The algorithm's still going to be on the order of n steps. Why? Because it might take you as many as all n steps to find it. Now, that's not necessarily going to be the case in practice. If I use big O as an upper bound, well, it would be nice if there's sort of a corresponding lower bound, especially if you want to consider not just worst cases, but maybe best cases. So what might we use here? Well, so this is a capital Greek omega symbol. So omega is the symbol that a computer scientist uses generally to describe a lower bound on an algorithm, often in the context of best case, though not necessarily. So a lower bound means how few steps might an algorithm take. And here too, same formulas, and we'll fill in these blanks over time. Some algorithms might always take a minimum of n squared steps, or on the order of n steps. Some might only take n log n, or log n, or 1. So something like linear search. When Stephanie started with linear search, she didn't get lucky this time on stage, but what if she had and the first door she opened were 50? How might you then describe the lower bound on linear search in this so-called best case using this list of possible answers? Yeah. Yeah, so omega of 1. So in the best case, the lower bound on how many steps it might take linear search to find something might just be 1 step. Why? Because maybe Stephanie had gotten lucky and we had pre-filled these lockers with the numbers in some other order such that she might have opened the first locker and voila, the number 50 could have been there. So a lower bound arguably could indeed be omega of 1 for linear search. And how about now for Jackson? He used binary search, so he dived right into the middle of the problem. But what would be a lower bound on binary search using this logic? Yeah. Yeah, so again, omega of 1. Why? Because maybe he just gets lucky. And indeed, right in the middle of the lockers could have been the number 50. It wasn't. And so more germane in Jackson's actual practice would have been the big O discussion. But big O and omega, upper bound and lower bound, just allow a computer scientist to kind of wrestle with what could happen maybe in the worst case, what can happen in the best case, and you can even get even more precise, like the average case or the like. And this is indeed what engineers might do at a whiteboard in a company, in a university, when designing an algorithm and trying to make arguments as to like why their algorithm is better than someone else's by way of these kinds of analyses. And just so you've seen it, it turns out that if some algorithm happens to have an identical upper bound and lower bound, you can actually use a capital Greek theta as well. And this is the last of the Greek symbols today. But a Greek theta indicates a coincidence of both upper bound and lower bound. That is, they are one and the same. That was not the case for our discussion a second ago of linear search, not the case for binary search, but you could use the same kinds of formulas if it turns out that your upper bound and lower bound are the same. So for instance, if I were to count everyone, like literally in this room, 1, 2, 3, 4, 5, 6, and so forth, you could actually say that counting in that way is in theta of n, right? Because in the best case, it's going to take me n points at the fourth, that your upper bound and lower bound are the same. So for instance, if I were to count everyone, like literally in this room, 1, 2, 3, 4, 5, 6, and so forth, you could actually say that counting in that way is in theta of n, right? Because in the best case, it's going to take me n points at the people in the audience. In the worst case, it's going to take me n. It's always going to take me n steps if I want to count everyone in the room. You can't really do better than that unless you skip people. So that would be an example off the cuff of something where theta is instead germane. Are any questions now on big O, on omega, or theta, which are now just more formal tools in the toolkit for talking about the design of our algorithms? Any questions? No? Seeing none? Yeah, oh, is this yes? No? OK. So we're good. So let's go ahead and translate this perhaps to some actual code. Let me go over to VS Code here, and let's see if we can't now translate some of these ideas to some actual code, not so much using new syntax yet. We're going to still operate in this world of arrays like last week. So let me go ahead and create a program called search.c. by executing code space search.c in my terminal. And then up here, let's go ahead and include our usual. So include cs50.h so I can get some input. Include standardio.h so I can print some output. We'll do int main void, which the meaning of which we did start to tease apart last week. The fact that it's void again today just means no command line arguments. And let me go ahead and do this. Let me go ahead and declare, just for discussion's sake, a static array, like an array that never changes. And the syntax for this is going to be give me an array called numbers using the square bracket notation. And I'm going to immediately initialize it to 20, 500, 10, 5, 100, 1, and 50, reminiscent of those same denominations as before. So this is a slightly new syntax that we've perhaps not seen. And the curly braces here, which are different from for loops and while loops and functions, just tell the compiler, please give me an array of whatever size this is containing those numbers left to right. I could alternatively use last week's syntax of saying something like this. Let's see, 1, 2, 3, 4, 5, 6, 7 denominations. I could alternatively do this. And then I could say numbers bracket 0 equals 20, numbers bracket 1 equals 500. And I could do this 5 more times. That's just a little tedious. If you know the numbers in advance, you don't have to tell the compiler how many there are. You can just let it figure it out that your numbers will be 20, 500, 10, 5, 100, 1, and 50. So this is how you statically define an array. All right, let me just go ahead and ask the user now for a number. We'll call it n by using getInt and prompting them for a number. So nothing new there. And now let me go ahead and implement linear search. And the pseudocode we had for this before used some array-like notation. Let me go ahead then and start similarly. For int I, and you almost always start counting at I by convention, so that's perhaps a good starting point. I'm going to do this so long as I is less than 7. Not the best design to hard code the 7, but this is just for demonstration's sake for now, because I know how many numbers I put in there. And then I'm going to do I++. So now I have the beginnings of a loop that will just allow me to iterate over the entire array. And let me ask this. If the current number at location I equals n, which is the number the human typed in, then let's go ahead and do something simple like printf, quote unquote, found, \n. And then, per our discussion last week, to indicate that this is successful, I'm going to return 0 if I found it. And if I don't find it, I'm just going to go down here and by default say not found, \n. And just for convention, just for good measure, per convention, I'll return 1, or really any value other than 0. 0, recall, means success, and any other integer tends to mean error of some sort, irrespective of the number I'm looking for. So just to revisit, the only thing that's new here is this syntax for creating an array of 7 numbers, these numbers. And then after that, we have really highlighted here an implementation of linear search. I mean, this is the C version, I dare say, of what Stephanie did on the board, whereas now the array is called numbers instead of doors. But I think it's pretty much the same. Let me go ahead and open my terminal window and run make search. Seems to compile OK, /search. And let's go ahead and search for a number. We'll start with what we did before, 50. And it's found. Let's go ahead and run it again, /search. Let's search for maybe 20 at the beginning. That one, too, is found. Let's run it one more time, searching for like 1,000, which is not among the denominations. And that one, indeed, is not found. So we've taken an idea from week 0, now formalized in week 3, and just translated it now to code. Questions on this implementation of linear search? Linear search. Nothing. Oh, so successful so far today. OK, so
Give me a minute, chat. Hello, chat. We are going to now jam game. All right. Kill. Elden Ring. Oh, it's my. I was like, why is there like a block cutting out there? It would be because of the microphone. All right, got it, got it, got it. Whee! There we go, chat. Got it, got it, got it. Going good, going good. Cool. Fuck. I did so well up until then. Okay. I think it was the... I think me changing directions is what fucked me. But I gotta... I think I've gotta, like, dodge into that direction. I think I've got the right idea. I don't think I executed it perfectly, though. Fuck! Oh, I forgot to change game! Hang on. Well, category, whatever. Category? Yeah, thank you, Panda. How you doing, bud? How you been? You behaving? Big poop. I could have parried that, but I wasn't sure I had enough time after the jump attack. Cool, cool, cool. Shrek watch through. Yeah. Ugh. That was terrible. How you doing, Shady? You winning? Ugh. Doing good, just settling down from work. Oh, yeah? Is the settling going good? Ta-da. I was pretty stubborn in thinking I could get that. Wow. Actually, I wasn't sure I could. I was like trying to see anyway. I'm getting a pretty good feel for them though, which is good. Oh, that was terrible. I have no excuse for not getting that one. Yeah, shady. I love that PS2 sound, man. It's so good. Yeah, Tom? Yeah, childhood flashbacks of Need for Speed and Midnight Club. Need for Speed Underground or which one? Hits me right in the old grandpa. I get a really nice feeling when I hear the PS1 sound as well. I like them. Underground 2? That makes sense. Those were really good games, man. You miss Dino Crisis? I don't know if I've played that one. There's a, so, there's the beginning of Donkey Kong Country on SNES. I love that beginning. Do-do-do, do-do-do-do. Do-do-do-do-do-do. Twisted Metal, Cooming. I should probably put the Donkey Kong Country one in. Like, there's so much music from like the Donkey Kong Country that's like so good. A lot of like Nintendo like music is so good. Crash? Yeah. I love Crash's music too. I might start making like secret commands again and just put like what do you call it? Sound bites attached to them. This time. instead of just random messages. PS2 best console. I believe. Oh, fudge. Can you do me a favor, Tom? Can you do !death space 5 for me? I want to know if it does do what I think it does. If it does work. No. So !death and then space 5. Okay. It does. Thank you. So I can now make commands that have got like spaces in between them. I just wanted to confirm that it did work. Thank you. DEFCON 5? Yeah. Alright. See if I can add some random ones like that then, sure. Hashtag PS5, not my console. I haven't... Well, I mean, yeah, it's pages, I guess, at the moment for you, Tom. I do want to play a few games on there. Like, the remade Demon Souls would be fun. It looks visually amazing. What else? There was the new Final Fantasy. I think it's like 16? No. Is it 16? I don't remember what the... I think it's 16. That's only on PS5. It's mine, but she does make a convincing argument. Yeah. Alright, this is what we messed up before. I think this is the way to do it. Fuck! Maybe it's not the way to do it. I don't know. I've only tried that like 2 times now. We'll see. I am gonna clip it and have a little look. You bought that? Still yet to really play it? I'm scared of the death mechanic. Oh! In the Demon Souls thing? Yeah, I didn't care as much. About it. Then don't die. If you play the other Souls games first, buddy, the difficulty isn't within, like the bosses and all of that, really. The difficulty is in, like... Not sure how it all works. Burb? No worries, Tom. It's not so much in the, like... Yeah, in the, like, death part. Like, the bosses aren't all that hard, okay? Especially when you realize that, like... So instead of having, well, I'm blocking it right now, right? But like the Estus flask, now you've got like 13, so it has like, you can get like 50 equivalent of like the Estus flask and basically never die, bro. Like, It's not that bad. Like, the bosses aren't that tough, especially if you've played Elden Ring and I can't remember if you said you've played Sekiro. That's a lot, yeah. But the thing is, right, is that you have to farm these things with like souls, or like going out to like murder someone that drops it. There's a few like hidden things that you might not necessarily like know as well, like trying to find like the blacksmith might take you a minute. You got to the bull in Sekiro, not that far. Oh, that's pretty decent. Have you fought Lady Butterfly or not in the memory? Some people don't get to her until like later. But yeah, so I mean, you've been going through like the Dark Souls 3 stuff recently. You've done Elden Ring. You've done Dark Souls 2? Have you? Yeah, you said you did 2. I don't think you've done 1, is what you said, right? Or you have done 1. Have you done Bloodborne? I think you said the 30 FPS wasn't to your liking on Bloodborne. You did Dark Souls 1 with no DLC. Ah, yep. Yep, that's right. DLC's pretty good, by the way. I really enjoyed it. Yeah. Demon Souls itself is not that difficult, especially with, well, the remake doing the omnidirectional rolling, but you'll be fine. It sounds more intimidating than it really is. You have Bloodborne, but haven't played it. Great game. Definitely recommend it. I would say Bloodborne is, like, took a lot of notes, I guess, from how Demon Souls worked. Not, like, because Demon Souls acts more like Dark Souls, right? But, like, Bloodborne has, like, the healing kind of, like, mechanic, but they had a cap of 20 in it. But they also added, like the, I want to call it, like, grey health? Or, like, pink health in Bloodborne that, Demon Souls does not have. Which, yeah, makes it pretty fun. And it, like, really promotes you to be aggressive in Bloodborne, which is great. The Blood Vials thing kind of makes me sad, but I do want to beat it in the DLC and all. Yeah. There's some decent ways on how to, like, farm them too, but it's not that bad. Like, it can get annoying. For sure. But since, like, you're going to be playing it after, like, Dark Souls 3 and, like, Elden Ring and everything, I think you'll probably be fine. There's a few enemies that will, like, drop the vials themselves if you farm them. Getting, like, souls is not too bad. I'm really against farming in games, though. So, like, I can understand, like, not wanting to do that. I really enjoyed the DLC. The DLC was fun. And I feel like the game really promotes you wanting to parry in Bloodborne. Where, like, Sekiro forces it down your throat. which I loved. Okay. Maybe it's because I'm just going directly left. Fuck me. I feel... No, alright. Whoa, whoa, whoa. Huh. You parry with the gun, right? Or am I mistaken? No, you're right. 100%. You parry with the gun, man. They did a really good job with, like, timing and things in that game, man. Like, it's, like, the parries are so, like, they're really, really, really good, and they feel very satisfying to get. Alright. Okay, what is the problem? I don't... It must be that I haven't got, like, the correct angle, I would say. Can you... Oh, wait, yeah. Also, like, gun parry thing, like, genius. Like, it's such an interesting way to, like, make that mechanic. Also, so, like, Bloodborne doesn't have, like, all of the weapons that Dark Souls and all of that have, right? But they have, like, a level to their weapons that, Dark Souls and Elden Ring and everything doesn't have. Because they can let you, like, transform the weapons, which is, like, makes them have their own, like, unique weapon set. Which is, like, really, really fun. Isn't it limited because of ammo? It is. I did not enjoy that part. That I'll agree with. But there are ways around it. Also, not every boss is parryable in Bloodborne. Even with the gun. Which, kind of a shame, but understandable. B for Bloodborne. That's the way, Shady. Feel like I should have got that, but fine. Okay, here we go. Not gonna lie, I tried to jump and do that heavy attack, but whatever. Oh, I tried to dodge that, but I held the button for too long. Fuck! That move is really cool. I like it. That he does. Is the Zoro combo parryable? Is it that one he did there that I died to? I haven't gotten the opportunity to try as much as I would like. I've tried a couple times, but my timing's been off because I can't tell all the time when I'm close if he's gonna do it. My initial theory is no, but I do want to try more. Last week I finally did something I've been doing my whole last year. Unlocked my first jet in War Thunder. Hell yeah! Alright, this is the move. One of the moves. No! I didn't angle it correctly. Fuck! Which jet is it, buddy? That one? Ah, got you. Okay. It's such a cool, like, move that he does. I hope when you get his weapons, you can do it. F2H to the Banshee. Oh. Have you had a go at it yet, buddy? No! I left it too long. Bugger. Is it safe to assume this Banshee was free to play made as well, or did you buy some things for it? It has 4 20mm cannons. that allow heavy damage even if you only has sights on target for a second. Ooh. Fuck! I've dodged this before. I'm getting so annoyed. What? Oh, fuck me. I had the timing down at one point. Why am I struggling now? I... Fuck! It's free, but I've bought a premium account time for the first time this year. Oh, yeah? How's that been then, bud? Has it, like, increased... Does it increase how much XP you get or something, or...? Here we go. Time to slow it down. Maybe I did it too early, like just? Yeah, I guess too early. But, or is it too late? Because I definitely... hang on. Maybe too early. Because when I'm coming up, that comes through. My initial thought is that it's too early. But, I don't know. I don't know. Boosts to EP and creds. I've been free to play for, I don't know, 5 to 6 years, so I finally sold out. I get it, bro. I was like that for League of Legends for a long time. Friend of mine loves War Thunder. He plays it far too much. Or at least he used to. He spent quite a bit of money on it. I'm not sure how much. Ugh. Disgusting! I wish I bloody didn't roll backwards. I could have been fine. Don't look at me, chat. Don't look at me! Don't look at me! Alright, Consort Radon. Get pooped on. Oh! Fuck! That was probably the closest I've got. That's so little health. Played World of Tanks for over a decade and spent about $5 total. War Thunder has cost me the price of 1 year premium, which was on sale for 60 maybe? Oh yeah. One more parry would have done, rip. Actually, yeah, you're right. One more parry would have done it, more than likely. Ugh. If I could have dodged the incoming meteor attack, would have had it. That feels unfair there. I feel like that should have parried, but whatever, Trevor. I spent... Actually, I'm not sure how much money I spent on League Alertos, but I spent a bit. Especially during, like, my last year of play. That's the most I've probably ever spent on the game. Because I was buying their... Well, the equivalent of, like, a battle pass for them, okay? Whenever they would release one. Just about every single one. Didn't parry. Fuck you, game. Gross wallet warrior. Was, of course, man. I had to buy all of the skins, Tom. All of the skins that made everything, like, way, way, way better. I played so much in my last year because of those battle passes, bud. I played so much. JK. No. Definitely, yeah. Yeah, I only spent more on War Thunder because we have more. We were poor as fuck when I was playing Water Tanks regularly. Yeah, I was getting, well, not super decent money, but like I was doing okay. Wasn't a big deal. He did it. He started it, and I brain farted. Fuck! That was when I should have tried the parry. I got stuck. I was like, dodge. Oh wait, I can parry, and then I fucked it up. Ah! Fuck. Close. I knew I should have dodged, but I knew I could parry that if I had enough time. I just wasn't sure I had the time. Clearly I did not. Looking at memes, chat. Laughing at the refried beans joke. Oh, you slut. Ugh. Hmm. Hmm. Nope, that was the wrong button. Burritos with carnitas, refried beans, and rice sounds delicious. I'm famished. Hell yeah, bro. Okay. Hey man, I think that guy finally stopped. Hey, I'm glad. Anytime I eat, I always think of the Dragon Ball eating scene where Mr. Satan loses to a gentleman. Oh, to be a gentleman. Lord Goku, Vegeta, and Gohan just chowing down. Yeah. Hello. Give me a minute, chat. Josh, Liffy out there. Give me a minute. Hello! Hmm? Give me a minute! Alright, I'm back. Hello! Hey, Kiff! Hey, Liffy! Hey, Eno, welcome back! I had to run off and pee. That guy finally stopped, so I did fall asleep though. I put my fan on to compensate with the noise. Josh? Yeah, I'm here, bud. Now I'm gonna get some sleep. I'll be good looking again. Just for context chat, there was a guy fixing building something at like 12:30 in the morning, so Josh and me were like, what the fuck is it this time, bro? Later, Enor. Yeah, poor Enor had some guy hammering shit late at night. It's... don't ask me why, I have no clue. Pretty sure that's too late to be doing anything. Although I don't know the, I don't know the things. The time for Enor over there. I mean, sorry, not the time. The laws. Ugh. How you doing, Kev? How you doing, Livy? Had to put socks back on. You're doing good? Hell yeah. You're okay? How are you, kid? What's up, Liffy? Why do I suck at this game? I'm the greatest. What do you mean? Why are you a negative Nelly? Never too late if you're on drugs. Is that how it works, Tom? Never mind then. Did I check your DM? I did. I didn't answer because I'm not sure. I'm giving it some thought. Is this been a minute? You know what time it is? Friday, 16th May, 2025 at 2:56 a.m. Yeah, buddy. What happened? I guess we'll just all have to be there, right? I hope you've been well, Chiz. Who knows? Yeah. We'll all have to be here. Hi, Tom. Yeah, you figured? Hmm. Hopefully you die. Tom! Jesus! $28 is good enough. Dying on level 28 is crazy. Not if level 30 is max. Jesus. I love jalapeno chips. They're great. 120 is max? Maybe. Maybe we'll get some shit that lets us live until like 200. Who knows, Chiz? Hey, bro's playing Daisy. Go get him, bud. People like back in the Bible, like living 900 years. True. Easy peasy. People taking, you know, your, like, loved ones to meet your, family for the first time. Meet your 900-year-old great-great-great-great-great-grandpa. Yeah, Sonny? Which one are you again? Easy, just no McDonald's, and we should be good. Is that how that works? Damn. Well, I've already failed then. Oh, I'm gonna have to go wash my hands. Fuck! Oh damn! Special Forces being a bot in here. Could one of my lovely mods please ban his ass? Was it showing you? Was it showing you? Oh, I'll be back. Quick. And I just have to watch my head real quick. Ugh. I'm back. You're gonna have to ask Kate. True. Give me a minute, Sean. Okay, we're back. From outer space. I'm so sad. Hey, back. Hello, Lef. What are you up to, bud? You been good? Kicking butts, taking names? You can join in the Discord, by the way, Livy. Or anybody else that wants to. Must be fairly early in the morning for you, bud. What time do you head out for work? Ha! Go. Fuck. Go. Okay. He still hits me on the second one. Fuck me. Hmm. Okay. I'm gonna try something. Wah. You want to know something that's oddly satisfying? Let me hear it, bud. Ah, Huh. Damn, did that hit me anyway? Damn, bro. Hmm. Thought I did better there for a minute. I guess I should have just kept rolling the one way. Listening to a dog crunch on chicken feet. I bought Cha-Cha some as a treat, and damn is the crunch great. Yeah. How many has she got? Back in New Zealand, when my mum was still alive, we used to buy chicken necks for my cat. She loved them. She would get so happy. When he does that, I gotta think of a better roll there. Maybe just roll backwards rather than off to the side. I don't know. Rolling backwards seems like a wrong idea, though. I don't know, around 2 dozen. Obviously not all at once. Her favorite is by far chicken hearts. Oh, yeah. So, like, we could get like chicken necks in New Zealand, like super cheap. So it was like pretty good for like the cat. She absolutely loved them. Do you guys get like Cha-Cha like pig's ears or anything or no? Because that's a fairly common dog thing to get in New Zealand as well. For dogs, obviously. Oh yeah, bro, we saw nice by the way. We saw a really friendly red dog today. I'm gonna post up some a picture of it tomorrow on my Twitch story. Damn, Kate, you hear that, did you, Tom? She can't have pork, but we get her beef and buffalo ears. What, is she allergic to pork? Buffalo ears would be great. Essentially like the same thing. I don't know if it's the smell of like the ketchup chips that Kate has or not, but like I'm slowly like getting converted on like thinking that they smell good. I didn't think that would be a thing for me. Maybe it's because it's not like... I don't know. Like, I had tomato sauce chips in New Zealand, and I thought they were gross. These ones smell better. They're almost spicy. I think I dodged 2? I've got to leave it, like, even later, I guess. Like, when do I... She gets sick when she eats it, so that's what we think. Well, yeah, no, that'd do it. Yeah, if she gets sick doing that. I'm, like, looking at, like, a clip, like, every, like, freaking few minutes. That wasn't from just now.
And we say bye-bye.
Okay. Thank you for the lurk, Tom. Kinda odd, but she can still munch on pork bones, no problem. That's funny. Too early, bro. Maybe. Oh, it might not be. Maybe I'm doing it too late. What if I did it... Because I've been trying to, like, time it. I don't know, because when I did it before, right? I was, like, in the initial stages of, like, the roll. Like... I was... How many do I get through? Because I roll quite early. I think I get past 1. And then when the second one comes, it fucks me. And the third one obviously still does. I get the next one, but then after that I die. Hmm. So it's either go earlier than I expect or later than I expect. Honestly, like, looking at the... when he, like, lights up, it makes me think that's when I'm supposed to roll, but... like, that's supposed to be the visual cue, but maybe it's not. Is this boss related to Nicola? Yes. What did you delete, Liffy? Were you Big Dum Dum? Is this boss related? Oh, no. Yeah, well, you are Big Dum Dum, yeah. You repeated the same thing twice. Ooh. Big Dum Dum, Liffy. Himlo? Hey, Buzz. How you doing, buddy? It's good to see you. Siblings? Yes. They are. Half brothers. Just got home from work, 2 a.m. here, having dinner. Oh, what you having for dinner, bud? Welcome home, by the way, my friend. I'm sad the parry missed. Steak and fries, nothing much. Oh, yum. That's it, I'm making food. Yeah, are you? Why do I Shady, if you're there, do you remember what the outfit I was wearing was when I had the fingers robe? Did I change much else, or did I literally just change the chest piece? Yeah. You see, Shady is my fantastic outfitter, okay? And he knows everything that I wear to every stream. He's like, today, yes, go. And then, like, you know, when it's an off day, he's like, you need to go back. You need to go back to the wardrobe, Josh. Glad to be what made you want to make food. How steak and fries is great, bro. That ain't nothing much. I love steak. Kate goes crazy for steak, buddy. Yeah. She goes feral for steak. Like, she was telling me that the steaks I pick out are like piddly in comparison to what she wants to get. I'm like, well, that's not actually normal on, like, the size that you get for steaks. Those are ridiculous, okay? In New Zealand, we don't get, like, steak... I mean, we can, but we don't generally get steaks that big. Give me the steak the size of a damn plate. You think it was just the robe? So... did I take everything else off? I don't think so, right? I think that was the only thing I changed. Yeah? Thank you. Give me this. Oh, wait. Kate would appreciate my steak portions. Always 500 grams plus. Give me the knife. I'll do it myself. Yes, sir. Yeah. I mean, I like steak too. It's just like the size of your guys' food is nuts. Plus vegetables, we're talking 1 kg of food on a plate. Damn, bro. I love veggies, man. Oh, are we getting a radish update today, by the way, Tom? Yep, true. That's why I'm asking him for, like, another update. So he can eventually make, like, a time-lapse of, like, the entire thing. Consider yourself an op if you hate veggies. We are. Yeah? Damn, that... Ugh. I don't know why that particular attack surprised me, but it did, and it left me, like... It made me hesitate just that little bit that I missed the parry. Ugh. Yeah, Kev. Look, chat. I recently ran out of rice, okay? And it is very sad. I had the last bit of it yesterday. It was yum. You ran out of food too? Yeah. We're gonna go shopping tomorrow. Oh, that reminds me. Should probably message Frank. Yeah. Yeah. I wasn't expecting you to do that. That was pretty funny. You wish you could go shopping? You need to wait for payday or something, Kev? Ugh. Yeah? Yeah. Nice. Yeah. A lot of our problem has been, getting transportation. I'm still working on that, chat. Been saving for a little bit for a car. No food until Friday. Oh, that's rough, bro. Ugh. They really do just look like dried dongs on the back. This is it. This is the one, chat. I can feel it in my bones. No, it was not this one. Never mind. I lied. Thanks. I was saving them for you. Yeah. I'm really sad. I'm gonna have to buy another controller. Because every now and then, I'm not pushing anything. And he'll just continue to walk forward. I'm really sad. Yeah, Shady. This is it! Fuck! I should have just smacked him. Ah, he was like one hit to phase 2. Fuck! I shouldn't have said anything. Ah! At the moment, every time I've said something, I just mess up. Oh, alright. Booting up Elden Ring right now? Yeah? Damn. Last boss I beat was Mesmer, I think, and the general on the boar guy. Ah, General Gaius. I gotcha. I gotcha. There's some optional bosses I'm guessing you haven't got to yet either. Radish update as a go. That's the way. Is it the distance that I'm at with him? Like, is it really that important? Or is it like, fuck, I don't even know. Ugh. This one may surprise you, yeah? Are you debating me for like a sprout there, Tom? You think you did it sooner than you're supposed to? Oh, the jagged peak area? You sure? Did you fight the boss there? We must look at Radish, chat. It calls to us. Here it is, chat. The Radish update. There's still no sprout. But you know what? We can appreciate it. It looks like dirt, yeah. See, Kate's excited, buddy. See? Hell yeah. So you beat Bale already, Buzz? Hell yeah. How many, Shadow Tree fragments have you got? You're at 14 right now, but I think I was around 10 when I beat Bale. Oh yeah, that's decent. I mean, anything after like 9 or 10, I think they like nerfed. Because they buffed things up to like 9 or 10. Well, at least I get to practice this. Did I? Huh. Maybe I don't jump that. Maybe I just roll it. That was interesting. Maybe I just roll continuously. Yeah. 'Cause... So... 1, 2, and I kept going. Wait, did I keep going? 2. No, I waited. Half a second. I wonder. Hmm. Hmm. Damn. Okay. Oh. I tried to dodge one way then the other, see if that did anything. Ah. He does change direction so fucking quick. If I... Huh. I'm, like, legitimately surprised it hit me. And then... Okay. Hmm. I messed that up. I wanted to jump attack, and I just hit R1 straight away. Ugh. I'm so used to doing that. Okay. I did actually remember to parry there. I didn't time it correctly anyway. Bugger. Oh well. It was close, but not close enough. Yeah, sorry, Shady. Still, as of yet, don't know. I would still there you go. I would still assume it's a no, but we're getting there. Right. Give me a minute, chat. Hello, chat. Oh, damn. Ugh. That didn't parry? Fuck me. Yeah. Fuck, that was close. Damn. Give me a minute. Okay. Ooh. Okay. There we go. Ah. Ba 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 ba. Okay. Chat. Maybe you guys can help me, right? Where does the iframe start on the light roll? Does anyone know? I kind of assumed this is what I needed, but maybe I don't. Maybe that's what's fucking me up. Cause but I'm so confused because I've done it before. I wish I had... I wish I had something like one of the old clips of where I did dodge it all so I could tell what I did. Bugger. Shady, you might have clipped it for me when I did do it. Did you? I'm trying to remember. Because I've asked you to clip a few things for me. If you do have it, my friend, could you put it in chat for me? I want to see what I did. Because I really thought that I had it down, and now I can't even consistently get it anymore. Wah. Meow. We're opening a cat grooming business, chat. It's just us grooming Claudio constantly. He's gonna be bald. Claudia is a baldy. Claudia is a baldy. Be careful, bro. Claudia is also clearly the reincarnation of One Punch Man. Oh, he's Saitama? That makes sense. 100 push-ups. 100 sit-ups. And a 10-kilometer run. Yeah, you having fun with Claudia over there, are you? I don't know if you can hear Kate's little giggles chat, but she's like thinking it's absolutely hilarious. Yeah. Fudge. Yeah. Oh, he's being all like stoic and like guiding you. Oh yeah. I'm being sent a vidya chat. A good vidya. Yeah. Huh? Is there sound to it or no? Yeah, you just like he's being self-conscious. Need to play some intense rock metal music when he's doing that. Yeah, Shady. I'm currently looking to see if I can find a clippy of me doing it. Okay. Well, it ain't that one. Not that one either. Could be this one. Nope. Not that one. Not that one. Fuck! I don't know if I'm gonna be able to find it again. Fuck! Ugh. Did you manage to roll that one, Shady? Because I remember, like, rolling it. I mean, I know I've rolled it before. And they haven't patched him to make that unrollable. There's no way. Ugh. Which one? In phase 2, where he does the meteor shower thing and then the shadow clones. I really didn't expect to struggle with it that much. I thought I had it down. It's bad. There's either like a super tight, unforgiving roll, or I'm fucking up somehow, which it could be. Oh yeah, it's specific angle? You think you could be... Is it really? That didn't work. Huh? Man, I didn't dodge any of those. Fuck. The shadow clones at the end of the attack, I think you need to vertically dodge left away from him. I don't know exactly though. What do you mean? So like diagonally, like left? Like that way? So if he's the door, right? I want to go like that. I kind of get like the end of that, but what about the beginning part? Like, I cannot recreate it, apparently. I'm struggling. Yeah, but away? So you mean, if he's the door, I need to do that. Away from him. Not roll towards him, away from him. Damn. Wait, for the whole thing? Just the beginning or the end? EP? You think...
Unfortunately, guys, that is going to be it for today.
You are correct, Tom, yeah. I think the whole thing again couldn't entirely be wrong. Bro. I am not doing so hot on this one anymore. It's very rough. Anywho. Unfortunately, though, chat. That is going to be it for tonight. Tomorrow, if I do stream, it's going to be late. And I'm not entirely sure I will stream. We'll find out together, to be honest. Huh? Because we gotta go shopping tomorrow, and it's gonna probably take a lot out of me. Alright? And I don't know what time I'll be back. Later? Yeah. If you guys could stick around for raid, that'd be cool. We refresh this. Yeah, we are gonna raid Killer B, alright, chat? Guys could give him some love. I would really appreciate it. He's again doing the speed runs for Dark Souls 2. And I will see you guys maybe tomorrow, maybe not. Thank you for being here. Nightbot, Liffy, Kate. Yo, Chris is here? Hey, buddy. Enor, Buzz, Panda, Tom, Shady. I don't know if Liffy's still here. Did I say Liffy? I feel like I did. Yeah. Jimothy, Kev. Cheers. I think that was everyone. You guys be good. Kick the butts, take the names. I might have to look up a video and just see how they're getting this, like, dodge, because it feels bad that I can't seem to get it. After, like, I did get it, and now it's not working. I'm doing something weird. I just haven't figured out what yet. Anyway. Be good! Bye, chat!